This video is going to walk you through the part of the notes where you're talking about the natural base e. So far in the study of math, we have worked with special numbers such as pi and I, which are basically symbols that represents a specific number. Pi represents 3.14159, I represents the square root of -1, e is just going to be another one of these special numbers, and it's called the natural base. The natural base e is irrational, so you can't find its exact value, but we can approximate it. We're going to skip this exploration as far as the video. However, this expression, if you plug in values, you will start to notice that you get close to the approximate value of e, which is about 2.718281828, and it continues from there. So if you look down here, it says the number is called the natural base e, or the Euler number, after its discoverer, Leonhard Euler. And the expression 1 plus 1 over x, all to the x power, approaches e as x increases. And you can see that it approaches that value of e. It never actually gets there because that ends up acting like a horizontal asymptote, but it continues to get closer and closer and closer to the exact value of e. And if you look down here in the core concept box, it says the natural base e is irrational. It is defined as follows. As x approaches positive infinity, or continues to increase, 1 plus 1 over x to the x power approaches the value of e, which is approximately 2.71828182846. Now, when you're working with a natural base, there's two ways you can look at this. When they're asking you to just simplify, e will act very similar to a variable and use our rules of exponents. So for example, for this problem, e squared times e to the fifth, thinking back to our exponent unit, when you're doing multiplication, we add our exponents, and so this would simplify down to e to the seventh. Likewise with division, it would follow the rules of exponents, and when we have a division problem, you would subtract your exponents. Now, 12 divided by 3 would give you 4. E to the fourth divided by e to the third, well, 4 minus 3 is 1, so it'd be 4e to the first, or just 4e. If you're taking a power to a power, remember this is when we distribute our exponent to all the exponents inside, including the 1 for 10 to the first. So that would give you 10 to the third, and this is where we multiply our exponents, times e to the negative 12x. Now that's not quite simplified yet. We can do a little more. 10 to the third is 1,000, e to the negative 12x. But just like we talked about earlier, we don't ever want to leave a negative exponent in our answer. So the best answer would be 1,000 over e to the positive 12x. Remember, the negative exponent just means the reciprocal of. So simplifying will really follow our rules of exponents. Now, if it asks you to use a calculator to evaluate each expression, there is actually an e function on your calculator. Now, I don't have a graphing calculator with me right now, but there is an e function on there as well, and I can show you where that is in class. But if you're on a scientific, e is typically located on top of one of the buttons. For example, on this one, it's right here on top of the ln key, which we'll talk about in this unit as well. So right there, that will allow you to calculate a value. So if I wanted to do, for example, this problem, e to the fourth, I would hit that function by hitting second, put in 4, and then it gives me an approximate value of about 54.598. And let's go to 3 decimal places just to be a little more accurate. Even if it's a negative or a decimal, it doesn't matter. Just use your function, e to the negative 0.09 power. Gives you approximately 0.914. Okay. Even if it's a fraction, it doesn't matter. It's your function. We'll do 3 divided by 4 to represent 3/4. And there you go. And this is where we're going to stop for today. So if you would please go to Blackboard, your assignment will be located there.